Hello, my name is Alex, I'm CTO of Smartz project, and today we are going to talk about blockchain. Asymmetric cryptography was invented decades ago. What's so special about blockchain? Let's dive into example. Let's suppose that you and your friends agreed that all of you have 100 credits. Any one of you can send a message that he or she sends 10 credits to any other person. And, for example, Alice can sign this message with her cryptographic signature so that everyone will know that this message was sent by Alice, and nobody could forge this signature. Okay, what problem do we have here? For example, Bob could send all of his credits to Peter, and at the same time he could make a transaction in which he sends 100 credits to John. Obviously, Bob can't simultaneously send 100 credits to John and Peter, but who will get these credits? It's very inconvenient to force John and Peter decide who gets the credits. These people could even be unknown to each other, and this situation called double spend. We need a way to prevent this. What is possible solution to this problem? One possible solution is to order all transactions. So, for example, we have initial on Bob's balance. Then he received 10 credits from Alice. Then he spent You see, in any moment of time, we could mathematically calculate current balance of Bob. For example, at this moment it's 100, at this moment it's 110, at this moment it's 10, and this transaction is illegal. We eliminating double spend. How this could be solved on a big scale? All transactions of users should be ordered, and who will decide on this order? Well, by the way, this order should be the same for all copies of this ledger, of this distributed public ledger. It's a synonym for blockchain. This agreement on public ledger called consensus, and there are consensus algorithms that solve this problem. Some party has to propose order of transactions, so all transactions have to be ordered. Algorithm of consensus consists of two rules. First one have to perform difficult calculation to propose ordering of transactions. That calculations are so difficult that only one person on average out of the network per 10 minutes can do it. That's why usually we have one ordering per 10 minutes. But there is possibility that there would be two or even more alternative versions of this ordering. That's why we need the second rule. Second rule says that the longest chain wins. In this case, clients should consider this chain as main. And usually this ordering computed not for each pair of transactions, but for a group of transactions called block. Blockchain connects blocks. Ordering inside one block is determined entirely by creator of this block. This is a technical approach to minimize amount of calculations and network communications during transaction ordering. You see, here we have block with 2 transactions, there's block with 1 transaction, there could be blocks without any transaction. As a user of blockchain, I don't have to solve these difficult tasks to propose my transaction, to include it in blockchain, and to determine its ordering. I can delegate this task to any other users, but I have to motivate his or her to perform this work for me. That's why we have fees in transaction in blockchain. These users in blockchains based on proof of work and consensus algorithm called miners. They are creating new blocks and receiving reward for their work. That's how new credits are created, because there have to be decentralized way of determining who is getting newly created credits. I've described algorithm of consensus called proof of work. It is the first algorithm proposed in Bitcoin blockchain, and there are many other consensus algorithms like proof of stake. My colleague will talk about it later. And by the way, I wrote a post with a detailed introduction to blockchain on Medium. A link you can find in the description of the video. Thank you for your time. See you next Thursday.